Well, good afternoon and welcome. Welcome to the latest in WebAge's Technology webinar series. Today's session is about Jenkins Pipelines. And I'll talk a little bit about content first, but just a few administrative notes first. Make sure I got my cursor. There we go. If you wish, you can check that you can raise your hand. I'm actually going to use the if there are questions, the chat feature. Yes, people are raising their hand. Great. I'm going to use the chat feature within within Zoom. Okay, no more raising hands. I'm going to use the chat feature if there are questions, and I'll invite questions at various points throughout the presentation. Slides will be available right after the presentation. I'm actually going to share a link with you at the end. And slides will be made available, I think, by email confirmation later as well. And an audio recording, well, screen recording, will be made available shortly afterwards. This webinar is based on a course that WebAge has. Sorry, chat messages, let me check. Good. Kinda, okay. So hold off on chat messages for a moment. Let me invite, I'm going to get distracted if I pay attention to the midline. This webinar is based on a course, Jenkins Pipelines. Jenkins Pipelines is a 2-day course which is intended to be a reasonably comprehensive view of the use of Jenkins pipelines. What pipelines are, the domain-specific language that underlies them, the Groovy language and elements of the Groovy language that are applicable to pipelines. And that might seem a little bit strange, but I'll talk shortly about what that is later. How to use libraries, some practices around the use of distributed pipelines operating across multiple machines, and some best practices. And this course is structured as a alternating between some lectures and labs at each half day. There's 4 labs that explore the concepts that we've been doing throughout the course. And the material for this presentation is drawn from this course. We've taken 2 days of material and are trying to compress it down into 1 hour. So this is very much just a sampling of material. And to be honest, I'm going to go through it relatively rapidly, so we may not have time to cover it in the same depth that we would in the course. To give you a bit of a sense of course material, I'll just flash this quickly. Agenda into split into day 1 and day 2, and the topics that we're covering. And you see that we're progressing through a series of topics around being able to understand and then build progressively more advanced pipelines. And we spend some significant time on libraries as well. And I want to call that out because part of the emphasis of this course is also on how to use pipelines in a scalable, sustainable way, to help not only the objectives that you have in a project to get a particular automation job done, a particular pipeline, but also to help an organization be more effective at DevOps. Now, by way of introduction, just a really quick moment about me. My name is Brad Brown. I am an instructor at WebAge Solutions and an independent contractor. Many of the people that WebAge uses for delivery are independent contractors, or practitioners in the field. So this material is not just course material to me. This is what I do in regular life. I spent about 20 years, almost 20 years at Loblaws. For those of you not Canadian, Loblaws is the largest grocery retailer in Canada and the largest private sector employer. And in my tenure there, I did absolutely everything there is to do in IT on the development side and the operations side. So at various times I've had national responsibility for application development, as well as for operations. That brings a perspective to topics like this course that's broad and occasionally, hopefully, a little bit deep. And let me just check one message quickly. Okay, quickly, thank you. Okay. Yeah, I was at the Mississauga office. So, but I am saying I'm going to try and focus here because I have a lot of material and not a huge amount of time. And I'm going to start with some pipeline concepts. Now, I'm assuming if you're here, a lot of you are familiar with Jenkins. I'm not going to go over what Jenkins is. But what is a pipeline? Well, a pipeline, in DevOps terms, we often speak of a pipeline as in kind of an abstract sense, as a sequence of actions And these actions are a kind of set of orchestrations, things that we're trying to control to achieve a goal. In Jenkins, a pipeline is a specific kind of thing. It's a kind of job that we can write using specific language and specific tools. And these pipelines give us the capability for implementing quite sophisticated automation. And pipelines are generally used to implement continuous integration or continuous delivery processes. In other words, processes that attempt to build a smooth, continuous flow process that runs right from check-in of code when somebody modifies code to delivery of working functionality in maybe a SIT environment or a QA environment or even production. And more generally than that, we don't have to use pipelines just for continuous delivery. We can use them for really any kind of automation task. There are lots of automation tasks that are not directly related to software development that pipelines are very effective for because they're such a general, broadly capable set of tools for doing automation. In Jenkins, pipelines are written in a relatively simple so-called domain-specific language. This domain-specific language allows us to describe the kinds of things that we're talking about at a relatively high level. So the language that we use to express the pipelines is, in some senses, comparable to the language of the objects we're talking about in the real world, at least in a sense. But we have the capability of augmenting that with Groovy when it's needed. Now, Groovy is a very rich, capable language. It's kind of, I would describe Groovy as what Java would be if somebody had written it now instead of 30 years ago. And Groovy gives us the ability to extend what we can do with the simple domain-specific language to give us the expressive power and the ability to write very sophisticated pipelines. Now, pipelines are not intended to be general purpose code. Even though we've got this sophisticated language, Groovy, pipelines are intended to be used for orchestration. A pipeline is intended to coordinate work. It does not do work. And what do I mean by that? Well, let's say, just for the sake of example, because this is an easy example to illustrate. Let's say that one of the things that we're doing is we have this automation task that we take a picture of something. Maybe it's on an assembly line. And then we want to do some image analysis on the picture that we took, and then make some decisions about which robot to control based on that image. Well, a Jenkins pipeline could conceivably be used to control the camera to say to take the picture, and then to control the robots. Do this, move this the object to the left or the right, depending on what the result is. That's coordinating work. What we wouldn't do in a pipeline is the image analysis. Even though in theory we could express that in Groovy, because Groovy's got the expressiveness of Java, we could write that image analysis code. It would be the wrong thing to do. That work, the kind of work things, are usually done by things outside the pipeline, commonly shell scripts. But they might also be done by plugins. And plugins are capabilities that we add to Jenkins that perform specialized actions. And they're things that we can plug into the Jenkins environment that extend the capabilities of that environment that we can make use of in pipelines. Now, pipelines come in two flavors. There's a so-called declarative and a scripted pipeline. Now, these pipelines, these different styles of writing pipelines are more or less equivalent, but there's some significant differences between them. And a declarative pipeline is a pipeline, it's a style of writing pipelines that focuses on what the pipeline is, the structure of the pipeline and what it's trying to do. And it de-emphasizes how it works. Now, I've got a couple of examples that'll make that a little bit more concrete in a moment. But declarative pipelines are opinionated in the sense that to write in a declarative pipeline, you have to follow a set of guidelines. You have to follow a particular pattern. And it's kind of rigid. Now, that doesn't mean it's not capable of doing lots of things, but you have to do things a certain way. One of the results of that is declarative pipelines have very clean and simple syntax. But because of this rigid structure, they tend to be a little bit restrictive in certain circumstances. And in particular, we have limited flow of control. So it's a little hard to do things like looping and decisions. And there are constructs for it, but it starts to get really awkward. So we also have this other style of pipeline called scripted. And a scripted pipeline, you know, if you look at the code to a scripted pipeline, it looks more like a traditional program. It's got procedural code. It's more familiar to developers. But it's not perfect either. The syntax for doing certain operations in scripted pipelines can be kind of obscure. The way that you do things can require a little bit of syntactic gymnastics sometimes. That it's not really a big deal once you get used to it, but it's a little bit intimidating at first. The value of having scripted pipelines, though, is they're more flexible. There are some things that you can do, particularly around, again, flow of control, that are really only, I shouldn't have said possible, I should have said practical in scripted pipelines. Because we can do them in declarative, it just gets a little awkward. Now, neither scripted or declarative is better. For what it's worth, I would use, and I use, a declarative style pipelines for simple and straightforward automation where there isn't really a lot of need to have flow of control. And I like doing that because I find descriptives easier to read. And for people who are new to pipelines, or particularly new to programming, a declarative pipeline tends to be a little bit more accessible. But then I also use and would recommend using a scripted style of pipelines for more complex automation, where we need to really think about flow of control. And this is where procedural code tends to fit the model of what we're trying to achieve better. Now, this has been a little bit abstract about what the difference is. Let's make this a little bit concrete and spend a couple of minutes looking at some examples. Here's an example of a declarative pipeline. What this pipeline does is it says, I'm going to execute a bunch of code on this agent, node 1, a server that's called node 1. And I'm going to do 2 stages, and the first one is called source, and it's going to check out from a Git repository. And then in the second stage, compile, I'm going to make use of the Gradle tool, and I'm going to run a shell script that executes Gradle to build that application that I just checked out. Now, if we had more time, I'd go into a little bit more detail about what each of these lines meant and why they are the way they are. But keep moving. So I'm just going to show you the scripted pipeline. This scripted pipeline does the same thing. Now, you'll notice this looks simpler in the sense that it's got fewer lines of code. But actually, is it really simpler? Because there's a little bit more magic stuff going on. Look at that, the way that I've specified that shell command where I'm looking up the Gradle home. I've got to actually, what I'm literally doing is looking up a tool location and by calling a plugin and doing some replacement in a string before I send a command. Now, this doesn't really illustrate the depth of the difference between declarative and scripted, but it gives it a little bit of a hint of the difference between the styles. And we'll be exploring that obviously in more depth in the course. But what I'd like to do is give you a little taste of where we go with actually experimenting with this in a lab environment. Now, before I do that, I just got a message. At least one person says they're experiencing some significant audio issues. If a lot of people are experiencing audio, can you just send a quick chat just to let me know? Because I can't really tell. Okay, so there's definitely an audio issue. Okay, stop. No, I got it. So apparently there's an on and off issue with interference. It seems to back up. Nothing's changed on this side, so I don't think I can do anything about it. But I'm just going to persevere because, frankly, I don't have a choice. So. Yeah, okay. A few people are getting a burring noise. Okay, I don't get feedback, so I can't tell, but I'm going to hope this is okay. Yeah, I think I think the mic's okay. Yeah, I'm actually on the same setup no, there's no phone near the mic. I've been using the same setup I've been using to deliver a course this morning, and everything's been fine so far. So it may be a transient thing, maybe on our connection out. I do apologize. At this point, I'm going to just proceed because I think I need to. Okay. So I'm going to flip over screens for a moment. And here's our lab environment. This is the lab environment that we see in the course, and in the lab, instructions about how to do this. And I'm going to skip all that because I kind of need to. But I'm going to build by hand a very simple pipeline. I'm going to do that by creating a new job. And this job is going to be simple. And it's a pipeline job. And I'm going to skip a lot of the configuration and go right to the pipeline code. And I'm just going to key that code right into the editor. And so I'm going to create this simple pipeline. I'll walk you through what the pipeline is and what it does as I do that. So this pipeline, this is a scripted pipeline. And that first statement, node master, means it's going to run this code on master. Now, the configuration that I have in the lab environment has 3 separate Jenkins logically machines. Yes, the slide deck will be called. I just want to check. Okay, quick check. Are people seeing my Jenkins console? Yes, good, thank you. Someone said they had a blank screen, so I wanted to check. Okay, thank you. So I'm going to build up this pipeline by hand. I'm going to start by specifying that this particular pipeline is going to run on a machine called master. There are 3 machines in this particular environment, and I'll talk about the other ones in a minute. And the first thing that I'm going to do is I'm going to say that I'm going to start a stage called compile. Now, a stage is largely just a graphic thing. It's used to divide your work into sections. And this section, I've only got 1 stage so far. You'll see what it's used for shortly. And in this section, I'm going to run a few commands. First one I'm going to do is I'm going to say git. And I'm going to use get so I can't talk and type at the same time, to retrieve some code from a public GitHub repository. It's Redshift solution/Java load test. If you wish, you can get this code. It's publicly available. I left it open for everybody. And it's going to retrieve that code into the workspace. Then I'm going to execute a shell command. And I'm going to say, I'm going to use Maven to build that software and package the result. In other words, I'm going to end up with a jar file. And I'm going to, so that I can show that this worked, I'm going to say, I'm going to archive that jar file. What archive does is it takes some contents from the workspace, that files, and it copies them into the Jenkins environment. It saves them in the Jenkins environment. It makes them available. And there's a purpose why I do that later, but right now, it just shows that it works. And I'm going to save this. And I'm going to hit build now to run the job. And you can see my job's running. It's in the compile stage. It's doing its work. And it finished. Yay, and if I refresh, what you'll see is here are my successful artifacts, and I've got widget 10.jar. So the pipeline ran. It's a very simple pipeline. Go back to configure a second short. It's a very simple pipeline. But it illustrates the use of, this is all DSL. This is all pipeline domain specific language. There's no Groovy here. This is kind of simple constructs. But it should give you a taste of how straightforward it is to actually be able to build pipelines that do interesting things. This is a very small interesting thing because we have only a few minutes, but it's an interesting thing. Let's go back and look at, in a little bit more depth, some topics about the pipeline domain specific language. And again, we're picking a number of topics from the course material and compressing that into a short amount of time. And there's a lot more kind of full explanation in the full course, of course. Of course. So I've been using the word domain-specific language. What a domain-specific language is a computer language in this context, is a computer language. That's specialized, and it is intended to easily express concepts about a very specific domain, or if you want to say it in different words, about a particular subject matter. And in Jenkins' case, the Jenkins pipeline, the domain-specific language is about pipeline objects. It's about the things that we want to manipulate in the pipeline. If you think back to the pipeline that I just wrote, what were some of the statements? Well, they were like git and sh for shell and archive. Well, those are ideas in pipelines, and the language is talking about those directly. I don't have to do a whole bunch of scaffolding to like create variables that are members of a class and instantiate them and call methods to use the git class to get things out. I just say git and what I want. And that's what a domain-specific language is all about. Jenkins pipelines are built on top of Groovy. Groovy is the language that's used to build pipelines, and Groovy has features that, for various kind of language design reasons, make it a good choice for implementing domain-specific languages. So Jenkins pipelines are actually literally Groovy with a layer of domain-specific language on top of them. And that DSL is all around continuous integration and continuous delivery topics. Now, even though Jenkins pipelines use Groovy as a foundation, many of the pipelines that we use can be written entirely in pipeline DSL and no Groovy at all. The one that I just wrote, there's no Groovy there. It's just DSL. But an advantage that we have is the power of Groovy is available when we need it. Now, one of the things that we can do with these pipelines is we can have a set of actions that we can express in either a declarative or a scripted syntax. And the scripted style the declarative style of a pipeline is very rigid. You can see in the left on the blue, I have a very kind of rigid style of how we can lay out a pipeline. Whereas the scripted is less strict rules and is more procedural, and it looks kind of closer to what people would think of as procedural code. Now, it's worth mentioning that we do have some outs. If we're writing a declarative pipeline and we need a little bit kind of release from its rigid structure, we can actually wrap that in a script statement and make use of kind of some scripting that's inside a declarative pipeline to give it a little bit of the flavor of scripted when we need to. But in general, we have these, we're leveraging these two different styles to be able to talk about things that are of interest to us in writing pipelines. And some of those things that are particularly interesting are about agents and nodes. So this is a fundamental concept in pipelines. You saw that in the one that I wrote. Anything happening in Jenkins jobs runs on either agents or nodes. Now, they're actually the same thing. We just use different words. They're called agents in declarative pipelines. They're called nodes in scripted pipelines. No, don't ask why, I don't know. Now, what's actually happening here? And this is a really important concept. What's actually happening here is that the things that happen, the code that actually does things, is actually running on a node. It's running in a particular place. And that node will be any one of a number of machines that's set up to work as a cluster inside Jenkins. That could be a single machine, so there could only be one. But we could have environments, and I'll show you that shortly because I have one, where there are multiple machines, and I can specify where that code actually runs. That's a very valuable thing to be able to do. Now, the way that we actually deal with that is we have each node gets labeled with a tag, maybe more than one tag. And that tag is just a string. It just gives something about the identity of that particular node. And the rule is that a job or a part of the job can run on a node with a matching tag. So I'm going to flip back to my pipeline. That first line, node master, what that says is all the rest of this code is going to run on a machine that has a tag master. That's what it means. And what that lets me do is control where code actually executes. Now, that's an important concept because a job without tags will run on any available node. And if you have a cluster with a number of different machines in it, you could end up having your code run in places where you don't actually mean to. So an understanding of the idea of nodes and tags is critical to making pipelines work in anything other than a single server environment. And as we get into more use of continuous delivery and Jenkins to support DevOps, that becomes more and more common. Another core concept that's part of the domain-specific language is this notion of stages and steps. A stage is an arbitrary set of code that gets executed. And it has a label that's an arbitrary name. It's used in the Jenkins user interface. And it's a way of dividing your pipeline into kind of logical groupings of things. Yeah, I'm going to come back to that. It's a way of organizing your pipeline into logical groups so that you can see the progress. Again, we saw that. Here I have a stage called compile. And if I go back and look at the execution of this job, here's that stage. Now I only had one stage, so it only shows up in one place. But we'll see how that looks in just a moment. Another value of stages, though, is they group a bunch of pieces of code together, and I can have different properties for those pieces, that group of code. So for example, a stage could be set to run on a particular node, and a different stage could run on another node. Or I could have different sets of properties, different logging properties, different timestamping properties. There are all kinds of different things. So a stage is a way of grouping things, and the way it looks is, here I've got a stage, I've got a set of stages, and this particular fragment of code has two stages, set up and build. And let's look at this in just a little bit more. I'm going to take that pipeline that I had just a moment ago in the lab environment, and I'm going to extend it a little bit to add another stage. Actually, I'm going to run on a different machine. I'm going to go back to my code. And again, in a full classroom, we'd be developing those concepts over a little bit more time than just a few minutes and just showing it off. But this is the kind of thing we'd actually be executing in a lab, except you'd be doing it yourself. So I'm going to add I'm going to check chat in just a moment. I'm going to add another stage to this. I'm going to take the pipeline that I've already got, and I'm going to add another stage. And that's going to run on a machine called Linux. Now, in this environment, there are actually three machines. There's master, there's alpha, and there's bravo. There's just arbitrary names. Alpha and bravo also have a tag called Linux, which I'm using to indicate that they can run any Linux job. So this part of my pipeline is going to run on one of those. I don't know or care which one of alpha and bravo. And I'm going to have a stage called run tests. And what that stage is going to do in that stage, what I'm going to do is I'm going to execute a shell script to execute the program that I've just got. And what I'm going to do is I'm going to wrap it in a try-catch. Whoops, lost my cursor. I'm going to wrap it in a try-catch block. Now that's a little bit of Groovyism, but it lets me take advantage of some of the programming features of a modern language like Groovy to try something and then catch an exception and deal with it. And what it's going to do, I'm going to simply run Java. I'm going to run execute this directly. Sorry, CP target. There we go. So there I've got a shell command that's going to execute. How do I know what that is? Well, I wrote the program, so I know what to do. And, oh, I'm not finished yet. I'm going to redirect the output from the program into a file. And if there's an error, if that program fails, I'm going to catch that error. I'm going to record the fact that the test failed. And I'm going to archive the output from the test. now I'm going to make one other change. Instead of archiving the jar file, I'm going to say stash under the name jars. And what that does is it takes the files and stashes it for later retrieval. And I'm actually going to get them back here. So I just want to make sure I get my syntax right. So now what I've got is I've got a pipeline that does things in two different places. On one node, it compiles something and saves the results. It saves the binary. Then on another node, it's going to retrieve the binary, effectively install it. It's going to run it, and depending on what happens, if that test is successful, well, nothing happens then. If it's not successful, it records the failure and grabs the resulting output. So let's save that, and I'm going to run it. Now my fingers are crossed because I didn't test this before, and I'm going to check chat messages here. So a couple things. So you could tag this is going back a little bit. You could tag your nodes and set up scripts to perform a rolling deployment to confirm the first is completed before continuing on to the next one. Yes, absolutely. You can certainly do that. You got to write a little bit of code to make that work, but yes, you can totally do that. Do stages and steps have exception handling? Well, not natively, but you implement it. That's what I just did. That try catch block, that's how I chose to handle exceptions. If you don't do that, then if you don't use the try catch block, then what the default action is if a step fails, it terminates the pipeline. And I didn't want that to happen. Can a value be passed from one stage to another? Yeah, actually it can. So this is a topic I wasn't going to go into in this session because it's short. But actually, no, you will see it later. You can have a variable that's set in one stage, even on one machine, and referenced on another machine. And that will totally work. And the reason it works, go back to my code for just a second, is this pipeline is controlled by master. So master is the Jenkins server that's pulling all the strings. But these individual things are happening, they're being sent down to a node. So this get statement is actually executing on master. This shell statement is actually executing on Linux. But master is controlling the pipeline execution, and it can keep track of variables. So yes, it totally does. Okay, so cool questions. Now, I'm going to return for the sake of managing time here and give you a little bit of a taste of another chapter around Groovy for pipelines. And here, we're going to introduce a few things about Groovy, the language that pipelines are built on top of, but also the language that we can use to extend the capabilities of pipelines. Groovy is a very rich, expressive language that can support the development of any size application, enterprise scale applications. It is a language that's, I don't want to say derived from Java. It shares a lot of philosophy of Java. And it's a little bit more than that. It shares a lot of Java's DNA because it actually runs inside the Java virtual machine. So Groovy belongs to a class of languages called JVM languages. They all work inside the JVM. And that means they interoperate very, very well with Java. That's a big advantage for enterprise scale development because you can make use of jars, classes that have been built for Java inside Groovy. But Groovy is also a modern language, and in so many ways, it's got all kinds of features that are things that if people were redesigning a language today, they would have done differently than they would have in Java. So it's Java-esque, but it's really much more modern than that. Because of some of these language features, it's found a place in a number of different scripting use cases. Jenkins is the one that we're exploring here, but it's also used in Gradle, which is a build manager. It's the native scripting language of Gradle, and a number of other cases. And this, in this material, we focus on Groovy's use inside Jenkins pipelines. Now, there are features that are commonly used in pipelines. There are features that we use inside libraries that we use in Jenkins. In the course, and certainly in this material, we don't really talk much about classes and object-oriented programming. And there's actually a whole raft of things that, for various technical reasons, don't really work. Don't really work inside Jenkins. There are certain Groovy features that, for reasons that I can't go into here, just aren't available. So you work with a subset of Groovy. Nevertheless, we want to be able to make use of common features. Here's the canonical hello world. And all this is doing is illustrating the fact that, I don't have a lot of extra scaffolding. If I want hello world, I just say hello world. Okay. And that's kind of a nice thing. That simplicity means that Groovy is a useful tool for extending pipelines. And what pipelines literally are is Groovy with a bunch of extensions. Groovy pipelines are the native language for Jenkins pipelines is literally Groovy. And all those DSLs, they're things that have been added on top in the Groovy language. So this allows us to make use of these capabilities to make a very good scripting language that doesn't require a lot of scaffolding code. It has a fairly simple syntax that's relatively unfussy. It's got a few things about the syntax that are going to strike you as odd the first time you really spend some time using it. You get used to it. And it's useful to understand the origins of the pipeline in Groovy to understand why the syntax is the way it is. And I don't want to be scary about the syntax. It's not particularly odd. It's just a little bit different in a few cases because of the way that the DSL, the domain-specific language, has been implemented on top of Groovy. And again, it's something you get used to very, very rapidly, and appreciate it's actually very elegant how it all works. So I'm going to pick a few pieces of material from chapter on extending pipelines with Groovy to give you some notion of how we can actually make this a little bit more concrete and actually do some things inside pipelines, making use of some of these Groovy features. One of those is around functions. So the pipeline that I showed, it's pretty straightforward. It's just a bunch of statements. But if you're writing code of any complexity, one of the things that programmers will do is they'll write a function to capture some idea. Here's a very, very simple function. This was used just for illustration. I'm creating a function called longer. What longer does is it takes a name and it takes a number of times in order to repeat that name. And all it does is it returns the name with that number of times separated by spaces. So if I call longer Alice 3, I'm going to get Alice, Alice, Alice. Now, okay, this is not a particularly interesting function. I kept it short just to make the point. But a function can encapsulate kind of any set of capability. And I'm going to show that in the lab environment in just a couple minutes. Because a very common pattern for pipelines that are of more than trivial complexity is to build a bunch of capability inside a function and then make use of that function over and over again. And I don't have time to show it in the lab environment here, but I can also take those things and move them into libraries and provide consumers with library functions that do things. So I could write a function that, say, for example, performs a deployment onto a particular server or a server that I specify. And then I could give it to somebody so that all their pipeline has to say is deploy. I could say deploy onto server XYZ and deploy the package ABC. All I need to do is call the function. You take that idea and it should be clear that I can make these pipelines that can have really, really rich complexity that's accessible to people and controllable for the enterprise, because I could have a central group create that library function, and the person who's making use of it doesn't have to know how it works. Okay, I'm going to stop getting excited about that and finish my slides. Another thing that we make extensive use of that's a Groovyism is maps. Now, map is a particular data type, and it associates keys with values. So I can define a variable called colors, which is a map, and what it does is, in this case, it's mapping red, green, and blue to the hex values, strings representing the hex values of those colors. And I can access maps by key. I can look up and add things to the map. I can change values. And maps can contain kind of anything. So that red doesn't actually have to be a string. It could have been the hex value. It could have been an array of something. It could have been a block of code. You'll see that in a couple minutes when I implement another pipeline. But maps are a feature of Groovy that gives us a very, very powerful capability of keeping track of bits of information, which sounds very abstract and hand-wavy, but it's extremely useful. Another thing that we make use of extensively in pipelines is this notion of a closure. Now, closure isn't a term that you may run into a lot in pipelines. A lot of people will use them without actually noticing them. But a closure is a block of code that, well, it's code. It can take arguments, it can execute things, it can do stuff. There are 3 examples of a closure in the bottom of the slide. The third example, the last example that I think you can see my cursor is here, is actually a re-implementation of that longer function. It's the same thing as that longer function, but it's an anonymous block of code. Now, that closure can be passed as an argument to something and made use of, and here's an example of that. And closures are kind of everywhere inside pipelines, even though you don't notice them. So here's a pipeline definition. It's got a number of closures. After the pipeline keyword, it's not a keyword, after the pipeline word, there's a closure. And that closure contains code. Agent any is a piece of code. Stages is a piece of code. Stages takes an argument, and that's a block of code, and so on and so on. So closures are kind of everywhere. Now, let's look at how some of these concepts come together. And I'm going to completely admit that this has been a whirlwind. A lot of the way that fits together may not make a lot of sense because we haven't had the depth. But I want to show you what some of the result is. I'm going to go back to my code. And I'm going to create a pipeline that does something kind of sophisticated. Whoops. First thing I'm going to do is I'm going to keep track of pieces of code that I'm going to execute dynamically. So I'm going to create a variable called builds, which is an empty map. And then what I'm going to do is I'm going to write a function that tests my application. So I'm going to create a function called test app, and it's going to take an argument called int that takes a parameter called magic. Now magic, it doesn't have any special meaning. That's why I called it magic. It's just a number. And it's used to pass into the test. And what I'm going to do is I'm going to have a variable called return value, which by default is going to have the value OK. And then I'm going to try by code. I'm going to try and execute the code. And this is pretty similar to what I had before. But I'm going to do something a little bit special. I'm going to look up the value of magic when I'm executing that command. So I'm passing that into the shell. And the test results I'm going to save in a file where I'm going to use that value as magic as part of the file name. And if there's an exception, if it doesn't work, then I'm going to say that I failed. And I'm going to return the value. So there I've created a function. Yay! I'm going to chat messages when I finish typing. Then I'm going to do another thing. This is kind of another cool function, but it's going to do something different. It's going to make a build. It's going to make a build for variable n, and I'm going to create a variable I from that. Now, there's a Groovy reason for this, which I can't really explain now, for doing that particular thing. And what it's going to do, oh, sorry, I'm going to actually do it on this. No, I'm not. Okay. What this function is actually going to do is it's going to return, look what I'm returning. I'm returning literally a block of code. What that code does is it says, hey, I'm a block of code. I'm going to run on a machine that's got a tag Linux. I'm going to retrieve the compiled code. I'm going to run the test app by calling that function. And if it's not okay, I'm going to save the results. Kind of cool. I'm going to do another thing. I'm going to have a new stage called NQ builds. And what it's going to do is it's going to queue up a whole series of builds. What I'm actually going to do is I'm going to do builds that are numbered from, I'm going to run tests that are numbered from 1 until 50. Now, this is a little arbitrary, but. And the way I'm going to do it is I'm going to simply say, I'm going to insert into my map there we go. Yeah. The results of that function make build. So make build is actually going to return a block of code, and I'm taking that code and I'm inserting it into the map. Cool, eh? Okay, I need to delete that. And then the last thing I'm going to do is when I'm running, I'm going to have a new test, new stage, run tests. I'm almost done. This says parallel builds. What that does is it runs all those builds in parallel. This is kind of cool. Because watch what actually happens. Of course, let's assume this actually works. I don't have some typo. So far, it hasn't blown up. Okay, hasn't exploded yet. This is looking good. Just gonna wait for it to finish here. Hey, no typos. Let me just refresh this. And look at all these test artifacts that were retrieved. Now, what actually happened? What that pipeline actually did, and yes, the part of the point of the course is to show what that actually did, is it actually went and it built the software, stashed the binary, then built up a list of code blocks, 50 of them, and then ran them in parallel on those machines called Linux that have the Linux tag. And I'm going to run this again to show you what actually happens in the runtime environment, because this is really kind of cool. It's doing a lot of work dynamically. I'm running the job now. Now watch build executor status. There's the job. It's starting on master. Oh, it's queued up all the things that are waiting for execution. And now look, the running jobs are running in parallel on Alpha and Bravo. And they finished. It happens too fast to really see all the activity. But if I went into the log file, you could see what's happening, which I'm not going to do because I don't have time. And all that happens with a relatively simple pipeline. Okay, now there were a couple of chat messages which I want to check on. Okay, a couple questions. So this is pretty specific, but if we have multiple Docker or OpenShift container clusters, would I recommend installing Jenkins instance on each cluster? It depends. Yeah, it depends. So the what I'd actually suggest is it depends on what your use case is, but if you want to run builds inside containers, rather than install Jenkins inside the clusters, inside the cluster or inside the container, there's another way to do it. There's the Docker plugin for Jenkins has a mechanism for making Docker containers build agents. So what it would effectively do is if you have a cluster that it has access to, it would drive the creation of the containers in the cluster. And that's a much more direct way of doing it. Does it run equally well on Windows using PowerShell scripts? Yes, totally. There is, this is all Linux, but on Windows, the verb bat runs command shell. The verb PowerShell runs a PowerShell script, and PWSH runs a PowerShell, what's the thing they call for the cross-platform one? It runs the cross-platform one. So yes, totally. There's excellent support for PowerShell. Shared, I'm not sure what you mean. There's a question about shared pipelines. It's not clear exactly what it means, but I guess it depends on what the context is. If you're talking about sharing code, generally use libraries for that. So if I have a pipeline that's shared across a number of purposes, one way of solving that particular problem is to implement pieces of the code as libraries and then allow people to assemble their own pipelines from the libraries. That's the one, that's kind of what I would do most of the time. Is there a Kubernetes plugin for Jenkins pipelines? I don't know whether there's anything specific for Kubernetes. There's the Docker plugin, but that's for running containers under Jenkins. You can always use shell. You can do anything in shell. There probably is a Kubernetes specific plugin. I gotta be honest, I don't know. I'm not absolutely sure. Now I'm actually managing to not completely blow my time budget. Let me just go back. I'm gonna close with just 2 slides that are taken out of best practices. Best practices sections coming. So I'm gonna close with these 2 slides. Hit any additional chats. Here's a best practice that I know I've said it already, but it bears repeating. Pipelines are intended for orchestration. They're not intended for general purpose computation. The fact that you can write Groovy code and you can write kind of anything you want in a pipeline does not mean you should do it. For various reasons, pipelines, the code in pipelines runs very, very, very slowly relative to native Groovy code. And there's some very, very good reasons for that. But that means you want to use it for orchestration where that overhead of managing the code doesn't really get in the way. Now, that's a cost that's worth paying because the fact that the code runs slowly is because it's very robust and it's managed and it can run in an environment where there are lots and lots of machines, like my simple example where I've actually got 3 machines. Well, that's fine. This isn't really a limitation. Any computational workload you should do inside some other steps. I said shell. Just offload it outside. That's not a real problem. At the same time, pipeline code is real software. It might not be particularly big. My pipeline example was less than 24 lines of code. Real production pipelines tend to be a little bigger than that. But you may not have 10,000 lines of code like you would in an application, but it's real software and it should be treated that way. You should comment it, which I didn't. You should use libraries to factor out common code. You should be using source control. There are all kinds of things like that that we should be doing because it is real software. And some of the pipelines that I see with people I work with are literally, they're hundreds and hundreds of lines of code. So that's bordering on, you really need version control. You really should have comments. You should treat it like software. And that's an important best practice, I think. Now, I'll talk about next steps in a second. I got a couple of other chats to look at. Yeah, presentation is being recorded, and I'm also going to provide a link to the material. And are there built-in code templates you can customize for CI/CD? Excellent question. Are there built-in code templates? There are not built-in code templates inside Jenkins. Inside Jenkins, there's a feature, the snippet generator, that will generate code fragments. But what it's intended to do is generate a fragment for, I want to do a Git checkout, and I've got a bunch of parameters. What's the syntax for that? There are not templates for complete things. However, just do a Google search. There are some excellent, very well-written pipelines that have been published. I found a bunch of good ones on GitHub. There's one that I thought was really, really well done. The British Columbia government, I can't remember the repository name. British Columbia, the government of British Columbia has published on GitHub a bunch of templates for Jenkins Pipelines. It's published as a set of libraries and some sample Jenkins files. And it's just excellent. They're not the only one. So yeah, you'd end up with needing to kind of find some materials. There is certainly a lot of good material. The self-serving next step, of course, is if this has tweaked your interest, the Jenkins Pipelines course will run regularly by WebAge. It covers this material in much more depth, obviously, with a lot of hands-on material. And to follow up, there's contact, and I'm going to send out a couple things by chat. Sorry, I just have to